All right, so multiplying matrices. The important thing, the easiest way for someone to tell that you don't know how to multiply matrices is if you treat it exactly like scalar multiplication. Multiplying matrices is a much different process, and we'll do an example in a minute that'll kind of show you maybe a little bit of why and how we can use these matrices and why we would multiply them together. So multiplying matrices, you notice here, if you're using maybe your intuition, you might think, oh, do 2 times 1, do the corresponding pieces, elements in the matrix, 2 times 1 is 2. No, not actually, none of these answers inside this matrix would be correct. Multiplying matrices, repeat, is not anything like scalar multiplication. The process of multiplying matrices, and I told you that idea of rows and columns is a very important one, and it continues into this multiplying. The idea here is you want to think of rows first, columns second. We look at our answer matrix. To come up with, and this notation we use, oops, sorry, wrong number. We use to denote an element in the matrix, and the 1 and the 1 tell you what row and what column this is located in. It actually also tells you what row and column you need to use in coming up with the answer for this location. For this location, you'll use row 1 and you'll use column 1. And what this is actually called, if you want the technical name, this is called the dot product. To find this entry, what you're going to take is the first elements in row 1 and column 1, and you'll multiply those together. So 2 times 5, and to it you're going to add the second elements multiplied together. 1 times 3. That number simplified, 2 times 5 plus 1 times 3, gives you the element that's in that location. So you have to use a row from one of the matrices and a column from the other to get that actual location. So that's row 1, column 1. And I'll switch colors here. If you want to get this entry to the right, the location for this element was A12. So that tells you use row 1, and this time use column number 2. So if we do the dot product of this, and you take that first element times the first element in the column, and you take the second element in the row times the second element in the column. So 1 times 7. And I'm going to switch here so that we don't end up with a big mess. Just have the typed out versions here. So this was A11, row 1, column 1, A12, row 1, column 2. Now we're moving down to the bottom row because we're in the bottom of our answer matrix because we're in row 2 and column 1. So the dot product here would be first elements multiplied added to the second elements multiplied. Row by column, our last entry, A22, you want to use row 2 and column 2. So 4 times 2 plus 3 times 7. We simplify this to give our final answer. We have 10 plus 3, so 13. We have 4 plus 7, so 11. We have 20 plus 9, so 29. And we have 8 plus 21, so 29 again. So multiplying these two matrices together, and if you look at what our original problem was, not even close to just multiplying the corresponding locations. Why this is, or where you can see an example of this, we'll go through together. We can use this to represent some situations as you see here, we can come up with a couple different matrices to represent our example here. Local shop sells 3 types of pies. Beef pie is $3, chicken pie is $4, the vegetable pie is $2 each. So what I'm going to do is place that into, and actually I'm going to make this a tall matrix, and we'll talk about why later on. I'm going to put each of those entries into a matrix. So matrix, just a horizontal, vertical, aligned rows and columns, set of numbers. So that's one of my matrices. Oh, actually, you know what? I'm going to orient it the other way. 3, 4, and 2. My second matrix is going to represent how much of each item was sold. So I'm just going to put a bracket around those, and that's going to be my second matrix. To figure out overall, maybe at the end of Monday through Thursday, I'm going to figure out how much I sold total, what the total amounts I earned on Monday, Tuesday, Wednesday, and Thursday were. To do that, you'd need to use the multiplication. So if you were doing this individually, you wanted to figure out what you got on Monday from beef, you'd take 3 times 13. If you wanted to figure out chicken pie on Monday, you take 4 times 8. The idea is we can use matrices to do this exact same thing. So remember, and we'll talk about why this is later on, but our matrix is actually going to be, we'll talk about how you can figure this out on Friday, is actually going to be a matrix with 4, it's going to be a 1 by 4, it's going to have 4 elements in it. But we look at our matrix, as far as the multiplication goes, remember we want to go row matched up with column. So this is going to be row 1 in the first and column in the second if we want to find that element. So the first element, you think about how we would find the total on Monday anyway. This first element represents Monday, Tuesday is the second, Wednesday, and Thursday is the last entry. We're just figuring out how much money was earned each day. So if you think about how we would do this anyway, we'd take, like I said on the previous slide, 13 times 8, or sorry, 13 times 3, 4 times 8, and 2 times 6, and that would give us our total for Monday. So our total for Monday is 39, 32, and 12. So that's a total of 83. If you look at the second entry for Tuesday, we want row 1. This is in row 1. It's in column 2. So we want to use, I'll just put a different squiggle around here. We want to use the same row, but column 2. So 3 times 9. If we wanted to see how much you earned on Tuesday, 3 times 9, 4 times 7, and 2 times 4. The total for Tuesday, 27, 28, and 8 would give you 63. So $63 earned on Tuesday. On Wednesday, that's row 1, column 3. So we use the third column here, 3 times 7, 4 times 6, and 2 times 0. Didn't sell any vegetable pies that day. 21, 24, and 0. So that would be 45. And then on Thursday, row 1, column 4, 3 times 15, plus 4 times 6, plus 2 times 3. So 45, 24, and 6. I'll give you 75. So our answer matrix shows earnings on each day, 83, 63, 45, and 75. The idea was we can take those 2 data sets that are related, and we know that to multiply them would give us the total amounts earned for each different type. And that's kind of one of the powers of the matrices as far as multiplication goes. So what might be a good idea is for you to go ahead and stop the tape and practice You know that this matrix, or I'm telling you this matrix, is going to be a 2 by 2. Look for your answer this way, and I'll go through the answer right now. So we're starting in row 1, column 1. So we want to use from the first matrix the row, the second matrix the column. So our first entry is going to be 1 times 2 plus 5 times 9. We move to the right. We're in row 1 still. Now we're in column 2. So we're going to scooch that over to column 2. We'll have 1 times 4 plus 5 times 7. If we go down below, we have row 2, column 1. So both of those rows need to go away, or both of those need to go away. We need to use row 1, column 2, 2 times 2 plus 3 times 9. Notice I don't ever have, when I do rows by columns, I don't ever have any extras. I don't have an extra number on the end here. The numbers always match up perfectly. So that was row 2, column 1. Last one here, row 2, column 2, 2 times 4 plus 3 times 7. If we simplify this, 2 and 45 gives me 47. 4 and 27, underneath that, 31. 4 and 35 gives me 39. And 8 and 21 gives me 29. So this is the basics. This is the basic idea of multiplying matrices. We'll continue on with this on Friday.